Welcome to Time Before Us, the channel where ancient history breathes again. Before time had a name, before the first human breath, there existed a world fierce, forgotten, and alive. Creatures of scale and silence, predators wrapped in feathers, titans that shook the earth, lives erased, bones buried beneath eternity. But they are not lost, they are waiting. This is Time Before Us, where prehistory worlds rise again, and the stories buried in stone finally speak. Chapter 1. The day the dinosaurs arrived before dinosaurs could ever rule the world. The world had to nearly end. Let's rewind time, not just thousands, not just millions, but over 250 million years ago. Earth was a terrifying, unfamiliar place. There were no birds, no flowers, no grass. Even the air felt alien. Lower oxygen, higher carbon dioxide, and a sun that scorched a dry, desolate landmass known as Pangaea. Imagine an entire planet with just one supercontinent, stretching nearly from pole to pole, surrounded by one vast, dangerous ocean. And yet, even in this hostile place, life tried to grow. But then came the biggest disaster Earth has ever faced, the Permian-Triassic extinction event. Sometimes called the Great Dying. This cataclysm wiped out nearly 96% of all marine species and over 70% of all land species. Volcanoes in what is now Siberia erupted for hundreds of thousands of years. The sky darkened. The ocean turned to acid. Oxygen levels plummeted. Everything gasped. And most of it didn't make it, but a few did. Among the survivors, small, strange reptiles known as archosaurs, the ancestors of crocodiles, pterosaurs, and eventually dinosaurs. These weren't the towering beasts we think of today. They were modest creatures, often overshadowed by larger reptiles like the therapsids, mammal-like reptiles. But the archosaurs had something unique: long, upright legs, faster metabolisms, and a knack for survival. They waited and slowly, patiently, over millions of years. They began to evolve around 233 million years ago, deep in the forests and floodplains of what is now Argentina and Brazil. Something incredible happened. A new kind of creature emerged, light, agile, fast. It had hollow bones, sharp claws, strong legs built for sprinting, and for the first time, it looked like a dinosaur. Its name? Eoraptor. This little predator, no larger than a dog, is one of the earliest dinosaurs we've ever found. Eoraptor was bipedal, meaning it walked on two legs. It had both sharp teeth and flat ones, suggesting it ate both meat and plants. In other words, a survivor. Not the king of its time, but a clever opportunist in a chaotic world. Soon after came Tyrannosaurus, a sleeker, slightly larger predator, with jaws full of dagger-like teeth. It could run, hunt, and chase prey down efficiently. It too came from South America, which during the Triassic was still connected to Africa and the rest of Pangaea. These early dinosaurs weren't yet dominating. They were just getting started. And they had competition. Crocodile-like reptiles called pseudotsuchians were the real rulers at that time. Some were armored, some were fast, some even walked on two legs. The dinosaurs had to fight for every inch of ground, living in the shadows of stronger, older lineages. But the Earth was restless. Around 201 million years ago, as the Triassic period came to a close, Earth experienced another crisis: massive volcanic eruptions from the Central Atlantic Magmatic Province. Lava poured for millions of years. Gases choked the skies. The temperature swung wildly. A third of life went extinct, and this time, the pseudotsuchians didn't survive. The dinosaurs did, and when the dust settled, they were ready. Welcome to the Jurassic period, the dawn of the dinosaur empire. With the playing field cleared, dinosaurs spread like wildfire across the globe. They were incredibly adaptable. Some evolved long necks and small heads to browse treetops, like the mighty Diplodocus. Others became fast, nimble hunters, like Coelophysis and Dilophosaurus. Every continent, from dry deserts to coastal swamps, began to fill with their footprints. But what made them so successful? Let's break it down. First, their posture. Unlike the sprawling lizard-like gait of earlier reptiles, dinosaurs walked with their legs directly beneath their bodies. This made them more energy efficient. They could run faster, travel farther, and support more weight. Second, air sacs. Many dinosaurs had a unique breathing system, like modern birds. Instead of lungs that inflate and deflate, their system was more like a constant airflow, fresh air in, stale air out, with no backtracking. This made them highly oxygen efficient, giving them the stamina to dominate diverse environments. Third, growth rate. Dinosaurs grew fast, faster than most modern reptiles. Some species like Maiasaura could grow from hatchling to adult in just a few years. That kind of rapid development meant they could outpace predators and adapt more quickly to changing conditions. Fourth, their eggs. Dinosaurs were egg layers, but many protected their nests, tended to their young, and lived in herds. Fossilized nesting sites in Mongolia and the western U.S. show that some species return to the same place year after year, much like modern birds. And finally, luck. As strange as it sounds, part of the reason dinosaurs thrived is because the right disasters happened at the right time. Each extinction event cleared the stage, and dinosaurs, uniquely adaptable, stepped up to fill the void. But don't be fooled. Their rise wasn't overnight. For millions of years, they evolved alongside giant amphibians, flying reptiles, and early mammals. It was a slow takeover, not a sudden conquest. But by the mid-Jurassic, their rule was undeniable, and that's when things got weird. Nature started to experiment. Take Stegosaurus with its bony plates and spiked tail, a walking tank with a brain the size of a lime. Or Therizinosaurus, a plant-eating predator with claws longer than swords. Or Camarasaurus, a gentle giant whose neck bones were filled with air sacs to lighten its massive skeleton. Some had feathers. Some had sails. Some had crests that may have amplified sound, letting them call to each other across vast distances. Some were tiny. That's something people forget. Dinosaurs weren't all huge. Some were no larger than chickens. The Microraptor was a small feathered dinosaur with 4 wings, one of the earliest gliders in history. The Compsognathus, barely longer than a cat, zipped through Jurassic underbrush on nimble legs, hunting insects and lizards. The variety was staggering. But through all this, something fascinating was happening. They were shaping the planet itself. Think about this. Hundreds of thousands of dinosaurs walking across plains, migrating in herds, stripping trees bare, dropping waste, and trampling ecosystems. Over time, they created grazing patterns, soil shifts, and even climate impacts. They weren't just living in their world, they were altering it. Dinosaurs were, quite literally, ecosystem engineers, and their reach extended into the skies and seas, though technically, true dinosaurs were land-based. Their cousins like the pterosaurs and plesiosaurs claimed the air and oceans with equal ferocity. But the most important change was happening slowly, almost invisibly, in the branches of their family tree. Feathers, that's right, feathers didn't begin with birds. Fossils from China's Yixian Formation revealed beautifully preserved feathered dinosaurs, some with full plumage, long tail fans, even color patterns. The Sinosauropteryx, for example, had banded tail feathers and could likely display for mates or intimidate rivals. The boundary between bird and dinosaur was starting to blur, and that would matter a lot. Because while we marvel at these giants, we often forget that they were not a dead end. They were the middle of a story, not the end. And that story began with a few survivors, crawling from the wreckage of the worst mass extinction in Earth's history. They weren't the strongest. They weren't the biggest. But they adapted, endured, and evolved into the most dominant class of animals Earth had ever seen. Dinosaurs didn't just arrive, they earned the planet. And the next 135 million years? That was their time. They would face meteors, shifting continents, climate changes, and fierce rival predators. But for now, the crown was theirs. Chapter 2: Giants, Thieves, and Oddballs. We often imagine dinosaurs as towering, sharp-toothed monsters stomping across ancient lands like monsters in a disaster film. But here's the truth. Dinosaurs weren't just giant predators or long-necked leaf munchers. They were far more diverse, far more bizarre, and often far more intelligent than we give them credit for. In this chapter, we meet the misfits, the thieves, the oddballs, the silent giants who didn't just walk through history. They redefined it. Let's start with the sauropods, the true giants of the dinosaur world. Now, when you think long neck, you probably picture Brachiosaurus or Diplodocus, right? But have you ever heard of Argentinosaurus? This beast may have been the largest land animal to ever live, stretching up to 100 feet long and possibly weighing as much as 100 tons. That's the weight of a commercial airplane. Walking. And yet, despite their size, sauropods were not slow, clumsy beasts. Recent fossil evidence suggests they moved in massive herds, migrating across ancient landscapes in search of food and water. Their necks were engineering marvels, constructed with air-filled vertebrae that lightened their weight while allowing them to sweep wide areas without moving their massive bodies much. It's easy to assume that something so big must have had a massive brain to match. But no, sauropods had tiny brains, some no bigger than a soda can. Still, their behavior suggests something surprising: complex social patterns, protective herding, and possibly even group parenting. And now for something completely different. Meet Tyrannosaurus. This dinosaur looked like it was built from leftover parts of 5 other species. It stood over 30 feet tall, walked on 2 legs, had a potbelly, a tiny head with a beak, and the longest claws of any land animal, each claw measuring over 3 feet. You'd think this creature was a predator, but no. It was a herbivore. A gentle giant with a nightmarish manicure. Why the massive claws? Scientists still debate it. Defense? Mating display? Foraging in high trees? The answer remains unclear. But one thing is certain: Tyrannosaurus didn't fit any rulebook. And speaking of odd, let's talk about the raptors. Now, thanks to movies like Jurassic Park, we all have a certain image of the Velociraptor: tall, sleek, and terrifying. But in reality, Velociraptors were only about the size of a turkey. They were fast, yes, and they had a sickle-shaped claw on each foot, which they could flick out like a switchblade. They hunted in packs, had advanced binocular vision, and yes, they had feathers. But there were bigger raptors too, like Utahraptor, which was almost the size of a small car and possibly even more dangerous than T-Rex in close quarters. These predators weren't just fast and strong, they were clever. Some paleontologists believe they used coordinated tactics to corner prey, something very few animals on Earth can do. And here's where things get a little philosophical. How do we define intelligence in creatures separated from us by 100 million years? Is it the ability to use tools, coordinate as a group, teach their young? Well, let's introduce another oddball. Troodon. This small, bird-like dinosaur had one of the largest brains relative to body size of any known dinosaur. Its skull housed a brain that, while small, was highly complex, and its eyes were massive, likely giving it night vision. Troodon may have been nocturnal, intelligent, and emotionally reactive. Some theories even go so far as to suggest that, had dinosaurs not gone extinct, Troodon's lineage might have evolved into something intelligent enough to rival humans. It's a wild idea, speculative. Yes, but it speaks to the potential locked in these creatures. Now let's meet the armored ones. Ankylosaurus. Imagine a living tank. covered head to tail in thick bony plates with a massive club at the end of its tail. If a predator got too close, Ankylosaurus could shatter bone with a single swing. Its body was so well protected, it's believed even a T-Rex would have had a hard time bringing one down. Then there's Pachycephalosaurus, famous for its thick, domed skull, up to 10 inches thick. Scientists long believed these dinosaurs used their heads like battering rams in dominance battles, slamming into each other like goats. But newer research suggests that while headbutting did happen, it may have been more about display and intimidation, like deer showing off antlers. Regardless, it's another example of how varied and strange these creatures became. And what about the thieves? Enter the Oviraptor, literally meaning egg thief. When its fossil was first discovered next to a nest of eggs, paleontologists assumed it was stealing them. But decades later, better evidence revealed the truth. It wasn't a thief. It was a parent. The eggs were its own. Oviraptors were bird-like, with toothless beaks, long arms, and feathers. They sat atop their nests just like modern birds, protecting their young. That one early misinterpretation stuck, unfairly branding them for years. And that tells us something else about dinosaurs. We're constantly rewriting their story. Take Spinosaurus, for example. For decades, it was portrayed as a giant, land-walking predator, maybe even more dangerous than T-Rex. But then, a fossil discovery in Morocco revealed something astonishing. Spinosaurus had paddle-like feet, dense bones for swimming, and a tail built like a fin. This wasn't a land predator, it was aquatic, the first known swimming dinosaur. Imagine a 50-foot-long predator, bigger than a T-Rex, gliding through the rivers of North Africa, snapping up fish with a crocodile-like snout. It changed everything we thought we knew about dinosaur ecology. Dinosaurs weren't just landwalkers. Some ruled the rivers. And then there are the weird little guys that barely show up in textbooks, but whose stories are no less fascinating, like Mononychus, a tiny bird-like dinosaur with just one finger on each hand. It looked like it came from a dream, small, feathery, with long legs and stubby arms ending in a single powerful claw. Scientists believe it may have used its claw to dig into termite mounds or burrow, a specialized feeder in a specific niche, or Cryolophosaurus found in Antarctica. Yes, you read that right. Dinosaurs once roamed the icy continent, though it wasn't icy back then. Cryolophosaurus had a strange, Elvis-like crest on its head and may have been one of the earliest large carnivores in the southern hemisphere. We even have beaked herbivores like Psittacosaurus, who were dog-sized and incredibly social. Fossils show evidence of parental care, social herding, and even gizzard stones inside their stomachs, used to grind tough plants. And here's one final twist. Dinosaurs didn't just grow horns or feathers or long claws for survival. Sometimes evolution simply showed off. Take Parasaurolophus, the dinosaur with a long curved crest on its head. For years, no one knew what the crest was for. Then, scientists built 3D models and realized it worked like a resonating chamber. Parasaurolophus could make low, haunting calls, like foghorns drifting through the forest. Communication, warning calls. Mating displays. Sound. Dinosaurs had voices. And maybe that's the part we forget. These weren't just bones. They were real creatures. They felt the sun. They heard the wind. They ran in groups. They protected their young. They fought. They fled. They evolved into all shapes and sizes, not just for power or fear, but to find a place in a world that was constantly changing. From the gentle giants to the misunderstood thieves. From the brainy bird-like raptors to the armored tanks of the plains. Dinosaurs were not just one thing. They were everything. And they set the stage for a planet unlike anything else in the known universe. One filled with ecosystems richer and more vibrant than most people ever imagine. This was Earth. When nature was wild, rules were flexible, and evolution was a mad artist. And trust me, The story's only going to get stranger, because next, we're going behind the scenes, into the dirt, the bones, and the labs, to see how scientists reconstruct these ancient creatures. From a scattered jawbone to a full skeleton, the detective work is just as fascinating as the dinosaurs themselves. Chapter 3. The science behind the skeletons. Let's be honest. Dinosaurs are cool. They're epic. They're cinematic. But behind all that pop culture wonder, behind the roaring movie monsters and towering museum displays, is something even more fascinating. The science. Because everything we know about these creatures, their shapes, colors, behavior, and even their extinction, comes from what seems like the most unlikely of sources: bones, rocks, and dirt. So how do we go from a cracked fossil buried in ancient stone to an accurate reconstruction of a living, breathing creature that roamed the earth 100 million years ago? Welcome to the world of paleontology. Part science, part detective. Work, part extreme patience, and a whole lot of imagination grounded in evidence. Let's begin where it all starts. In the field. Most dinosaur discoveries don't begin in glamorous labs. They start in remote, often unforgiving landscapes: the badlands of Montana, the deserts of Mongolia, the scrublands of Patagonia. Scientists spend weeks or months trekking into these areas with nothing but maps, digging tools, and a lot of hope, because fossils aren't easy to find. Sometimes they're buried under layers of rock, hidden from the world for over 100 million years. What they're looking for isn't always a full skeleton. In fact, it rarely is. More often, it's just a fragment, a tooth, a claw, maybe a jawbone. But in the world of dinosaur science, even a single tooth can reveal extraordinary information. Take the T-Rex tooth, for example. With its thick, banana-like shape and serrated edges, paleontologists can determine its bite strength, what kind of prey it hunted, even how it crushed bone versus slicing flesh. They can tell if it was a primary predator or a scavenger. Now let's say they find a more complete set of bones. What happens next? Every piece is carefully mapped, photographed, and cataloged before removal. Scientists use everything from tiny brushes to dental picks to jackhammers, depending on how fragile the fossil is. The bones are wrapped in plaster jackets for transport, like a medical cast. Then, they're taken to labs and universities around the world for analysis. But here's where things get interesting. Fossils aren't bones anymore. They're mineralized remains, bones turned to stone. Over millions of years, the organic material inside the bone is replaced by minerals like silica, calcite, or iron. So what you're holding is basically a rock copy of a bone, encased in ancient sediment. To get to the real details, scientists must prepare the fossils, often by hand, removing every grain of matrix rock, sometimes with microscopes, needles, and compressed air tools. This process can take months, even years. Now comes the magic. Once the bones are clean, paleontologists begin to reconstruct the skeleton. This requires comparing the fossil with known specimens. For instance, if you've got a partial femur from a hadrosaur, you might use similar species to estimate its full size and shape. They'll also use CT scans, 3D imaging, and digital modeling to rebuild damaged parts. Missing bones? Those are often reconstructed based on symmetry or from other fossil records. This is where science and educated guesswork collide. But that's just the skeleton. How do we know what dinosaurs looked like? That's where trace fossils come in. Things like footprints, skin impressions, and even fossilized feathers. These rare finds give us direct evidence of texture, movement, and even behavior. In 2016, researchers in Canada uncovered a fossilized nodosaur, an armored herbivore, so well preserved that its skin, armor, and facial structure were nearly intact. It was nicknamed the sleeping dragon, and it changed everything we thought we knew about dinosaur preservation. From it, scientists discovered scales, pigment cells, and armor layout, and suddenly, reconstructions became far more accurate, even More astonishing? In some rare cases, we found fossilized hearts, stomachs, and soft tissues, proof that the line between ancient death and modern insight is blurrier than we thought. Now, let's talk about movement. How do we know how a dinosaur walked? Scientists use a field called biomechanics, combining physics, engineering, and anatomy. They analyze joint shapes, muscle attachment points, and limb proportions. With software, they simulate how bones would have moved, how fast a dinosaur could run, how it turned, and whether it could jump or swim. In one study, paleontologists used robotic legs modeled after Velociraptor to estimate its running speed, concluding it could reach up to 40 miles per hour. Others used T-Rex leg bones to determine that while it was powerful, it probably couldn't run, more of a fast walker or an ambusher. How do we know how dinosaurs acted? It's not just guesswork. Fossil evidence tells stories. Take Maiasaura, whose name means good mother lizard. Fossilized nests show adult dinosaurs protecting their eggs and staying with their hatchlings, suggesting parental care. Other species show herding behavior, with hundreds of fossils found together, proof they moved in groups, maybe even migrating like wildebeests. Bite marks, healed wounds, and even feces, coprolites, give clues about diet, combat, and digestive systems. We found bones inside stomachs, fossilized vomit, and even fossilized dinosaur dung. Gross, maybe, but revealing? Absolutely. Now, a modern revolution in paleontology. Color. That's right. We may now know what color some dinosaurs were. How? Through microscopic structures called melanosomes found in fossilized feathers. These tiny pigment-containing organelles vary in shape depending on color, round for red, rod shape for black, etc. By analyzing their shape and density, scientists reconstructed the color patterns of some feathered dinosaurs, like Anchiornis, which had black and white stripes with a red crest. It's not full-color photography, but it's a start. And it shows us that our gray and brown vision of dinosaurs might be totally off. They could have been brightly colored, patterned, even iridescent, like hummingbirds or peacocks. Now let's zoom out. How do we know when a dinosaur lived? That's where radiometric dating comes in. Fossils themselves can't be dated directly, but the volcanic layers above and below them can. By measuring the decay of isotopes like uranium or potassium, scientists can date surrounding rock layers with stunning accuracy, often within a few thousand years. That's how we know, for example, that T-Rex lived 66 million years ago, while Apatosaurus thrived closer to 150 million years ago. And let's not forget DNA, or rather, the lack of it. Despite what Jurassic Park might tell you, we've never recovered intact dinosaur DNA. It degrades far too quickly over millions of years. The half-life of DNA is estimated at around 521 years under ideal conditions. After about 6.8 million years, it's all but gone. Dinosaurs went extinct 66 million years ago. The math just doesn't work, but researchers are still exploring ancient proteins, cell structures, and chemical residues that might offer biological clues. And who knows what the future holds. Now let's talk about museums. Ever been to one and seen a towering dinosaur skeleton? What you're seeing is the end result of decades of work, excavation, cleaning, restoration, mounting, sometimes even educated fabrication. Missing bones are often filled in with casts or sculpted models. Every museum mount is part real, part replica, part art, and always evolving. Famous skeletons like Sue the T-Rex or Stan have become icons. But even they've gone through reanalysis, repositioning, and reinterpretation as new science emerges. Because paleontology isn't static. It's alive, new. Discoveries happen every year, sometimes in dusty museum drawers where overlooked fossils are re-examined with new tools. Sometimes in the field, where a farmer stumbles across a bone and changes history. In the last 2 decades alone, We've discovered dozens of new species, rewritten theories about feathers, and overturned long-held beliefs about posture, diet, behavior, and even extinction. And perhaps the most important shift of all? Realizing that dinosaurs didn't go extinct. Because birds are dinosaurs. Every pigeon, hawk, and hummingbird is a direct descendant of theropod dinosaurs. That's not metaphor. That's evolutionary fact. Their skeletal structures, respiratory systems, nesting behavior, and even sleeping posture connect them directly to ancient raptors. So the next time you see a bird hop across your lawn or hear one sing in the morning, remember, you're witnessing the last living dinosaurs. And it all comes from the bones, the fragments, the traces, the silence of deep time, translated by human curiosity. In the end, paleontology is more than a science. It's a story, the story of how we've slowly, painfully, and brilliantly resurrected an entire world that vanished long before we arrived. A world that still speaks to us from beneath our feet. And that world wasn't just dramatic. It was brutal. It was beautiful. It was alive. And in the next chapter, we'll walk straight into that world, into the heat, the hunger, and the heart-pounding tension of prehistoric survival. Because dinosaurs didn't just exist. They struggled to live in a world filled with predators, prey, and creatures even deadlier than themselves. Chapter 4, Dino Drama, Predators, Prey, and Survival. When we think of dinosaurs, we usually imagine the kill, the chase, the bite. And yes, dinosaurs lived in a brutal world, one where staying alive meant always watching your back. But survival wasn't just about claws and teeth. It was about intelligence, adaptation, timing, and luck. For every predator, there was a prey. And behind every fossilized skeleton, there's a story of struggle, and sometimes strategy, in a world where one mistake meant extinction. Let's walk into that ancient drama, where survival of the fittest wasn't just a saying, it was law. Our story begins in the Jurassic period, a time when dinosaurs finally rose to dominance after millions of years of living in the shadows. It was an age of giants, from sauropods as long as 2 school buses to carnivores with teeth like knives. But make no mistake, size wasn't always strength. In this age, the real winners were those who could adapt. Let's start with the predators, the cold, calculating killers of their time. Take Allosaurus, one of the most feared carnivores of the late Jurassic. With a body length of up to 35 feet, it wasn't the biggest, but it was a master of attack. Allosaurus had blade-like teeth, strong legs for ambushing prey, and sharp claws that could slash open flesh like butter. Its skull was light but strong, with a unique hinge that may have allowed it to open its mouth wide, like a modern snake, delivering a hatchet-style bite. Instead of crushing bone like T-Rex would later do, Allosaurus may have used its head like a cleaver, striking with quick, repeated blows. Now imagine being on the other side of that encounter. Let's talk about the prey, the giants like Apatosaurus and Camarasaurus. These weren't helpless victims. They had whip-like tails capable of cracking like a bullwhip, potentially breaking bones. And they didn't travel alone. Fossilized trackways suggest they moved in herds, sometimes large. Defensive circles with the young in the center, much like elephants today. Safety in numbers wasn't a new invention. It was survival instinct, and sometimes the prey became the predator's downfall. Fossil evidence shows Allosaurus bones with crushed ribs, fractured skulls, and healed wounds, suggesting violent encounters that didn't always go their way. Life was a gamble, and even the most fearsome hunters didn't walk away unscathed. Now fast forward 60 million years into the Cretaceous period, when evolution went wild. Enter Tyrannosaurus rex, the undisputed apex predator of its age. Everyone knows the T-Rex, but what made it so dominant wasn't just size or teeth. It was a package deal. T-Rex had binocular vision, meaning it could judge depth and distance like a hawk. It had a bite force of over 12,000 pounds, strong enough to crush cars. And its olfactory bulbs, the brain region responsible for smell, were massive. This dinosaur could smell prey from miles away. But here's the kicker: T-Rex wasn't fast. Recent studies suggest its top speed was around 12 to 15 miles per hour. For comparison, a human sprinter can reach similar speeds. So if it wasn't a runner, how did it catch prey? The answer lies in ambush and efficiency. T-Rex didn't need to chase prey across open plains. It likely used its massive frame to lurk in forested areas, striking when its prey least expected it. Its powerful legs helped it burst forward with explosive force. Not for long, but long enough. And while we're at it, let's dispel a myth. Those tiny arms? They weren't useless. T-Rex's arms were short but incredibly strong. Each could lift over 400 pounds, and their bones were thick and fused like a wrestler's. Some paleontologists believe they may have been used to hold down struggling prey, aid in getting up from the ground, or even in mating behavior. So next time someone jokes about T-Rex's baby arms, remind them, nature doesn't build features without reason. But even the king had rivals. Meet Velociraptor, a large, feathered predator from the same era. It was fast, agile, and deadly in packs. Unlike T-Rex, it didn't rely on brute strength. It used speed, claws, and strategy, hunting like a wolf with precision and teamwork. Fossil evidence shows these predators lived side by side, possibly competing for the same food sources. It's the ancient version of lion versus hyena, raw power versus nimble tactics. Now shift your gaze to the skies and seas. While T-Rex ruled the land, the mosasaurs ruled the oceans. These marine reptiles weren't dinosaurs, but they were every bit as terrifying. Some reached lengths of 50 feet, with double-hinged jaws and conical teeth perfect for seizing slippery prey. Mosasaurs didn't just eat fish, they ate other marine reptiles. Some even consumed smaller mosasaurs. Their closest living relatives? Monitor lizards and snakes. In the air, the pterosaurs, like Quetzalcoatlus, soared above. With wingspans over 30 feet, they were among the largest flying animals of all time. But despite their size, they were likely lightweight, hollow-boned, and possibly scavengers, picking clean the carcasses left behind by larger predators. Now, let's not forget the herbivores, because while they didn't have fangs or claws, their survival skills were just as impressive. Take Triceratops, a three-horned tank with a massive frill made of bone. It didn't just look intimidating. That frill wasn't just for show. It protected the neck from predators like T-Rex, who often went for the throat. Fossils show evidence of healed puncture wounds, meaning Triceratops could survive a T-Rex attack and walk away. In fact, one T-Rex skull was found with a shattered jawbone, likely caused by a horn to the face. Then there's Ankylosaurus, covered in armor from head to tail. Its signature feature? A clubbed tail capable of swinging with enough force to break a predator's leg. Imagine a rhino with a sledgehammer attached to its back. That's what a hungry T-Rex had to deal with. Now, not all survival was about brute force. Some dinosaurs went the route of stealth, agility, or social intelligence. The hadrosaurs, or duck-billed dinosaurs, had few physical defenses, but they made up for it with speed, group behavior, and communication. Fossilized crests on their skulls, like those of Lambeosaurus and Cretaceous, may have worked like built-in horns, amplifying sound for group calls, mating rituals, or alarm cries. Others, like Tyrannosaurus, had flattened horns and massive nasal bosses, possibly for pushing matches or shove-in contests, a prehistoric version of sumo wrestling. And even the smallest dinosaurs weren't defenseless. Macroraptor, a four-winged glider, likely escaped predators by taking to the trees and gliding silently through forest canopies. Hypsilophodon, a small herbivore, had long legs and keen eyesight, perfectly built for darting away from danger. Survival was about specialization. You didn't need the biggest You just had to be the best at what you did, and sometimes survival meant coexistence. Fossils have been found of multiple species, predator and prey, living in the same ecosystems for millions of years. That kind of balance doesn't happen by accident. It requires an ecological dance, a push and pull between population, environment, food supply, and behavior. But nothing lasts forever. As environments shifted, new species emerged while others died out. Volcanoes changed the climate. Sea levels rose and fell. And every few million years, something wiped the slate clean, a new extinction, a new chance for life to try again. And in between those resets, dinosaurs played the game of survival. And played it well. They lasted for over 160 million years. For context, humans have only existed for 300,000. Dinosaurs faced droughts, floods, volcanic winters, and shifting continents. Some migrated thousands of miles every year. Others changed diets, behaviors, even body shapes to stay alive. They evolved armor, camouflage, speed, claws, communication, and community. And in the end, most weren't wiped out by competition. They were wiped out by the sky itself. But that story is coming later. For now, remember this: dinosaurs weren't mindless beasts. They were survivors. Every fossil is a scar from that fight, a broken claw, a healed rib, a trackway through ancient mud. And while we marvel at their size and power, the truth is, the most impressive thing they ever did was endure. Survival wasn't about killing. It was about living. Long enough to evolve. Chapter 5: Feathers, Colors, and the Truth About Scales. Close your eyes and picture a dinosaur. Odds are, you're seeing leathery skin, maybe some scales, and definitely no feathers. That image has been hardwired into our collective memory, thanks to movies, toys, and old museum models. But what if we told you that image is wildly outdated? That many dinosaurs were feathered, colorful, and far stranger than we ever imagined. Welcome to the Great Dinosaur Makeover, where ancient monsters start to look a little more like birds, and the lines between science and science fiction get blurred in the most thrilling way possible. For over a century, the default look for dinosaurs was based on the closest living reptilian relatives, crocodiles and lizards. Scales, thick skin, muted tones. These assumptions made sense based on what we knew. Fossils preserved bones, but rarely soft tissue. Artists filled in the gaps with gray, green, or brown, safe, realistic colors. But then something extraordinary happened. In a quiet corner of northeastern China, in the 1990s, paleontologists uncovered fossils from the Yixian Formation, a layer of sediment so fine-grained, it preserved more than just bones. It preserved impressions of skin, soft tissue, and most incredibly, feathers. Yes, actual, undeniable, fossilized feathers. These were not birds. They were dinosaurs. The first shock came with Sinosauropteryx, a small, two-legged predator covered in a fuzzy halo of filament-like feathers. It wasn't built for flight, not even close. But there they were, the earliest known protofeathers, likely used for warmth or display. And that changed everything. Soon, more feathered dinosaurs were discovered. Microraptor, Anchiornis, Caudipteryx, Utaranus. Some had wings, some had tail fans. Some had crests of feathers atop their heads, more flamboyant than a Vegas showgirl. Microraptor was especially shocking, a four-winged dinosaur that likely glided between trees, like a prehistoric flying squirrel. It had feathers on its arms, legs, and tail. Its feet were curved like a hawk's, suggesting it was a hunter, possibly swooping down from above. But wait, it gets crazier. One of the biggest meat-eating dinosaurs ever discovered in China was Utaranus, a cousin of the T-Rex that stood over 30 feet long. And yes, it had feathers too. That was the final nail in the coffin of the old myth that only small dinosaurs had feathers. If T-Rex's relatives were feathered, Could T-Rex have been fuzzy too? That question still divides scientists today. While no direct fossil evidence of feathers has been found on adult T-Rex specimens, some paleontologists believe juveniles may have been covered in feathers, which they shed as they grew, much like elephants lose body hair. So why did some dinosaurs have feathers? Flight wasn't the only reason. In fact, feathers likely evolved for temperature regulation, much like fur. Warm-blooded creatures, and many dinosaurs likely needed insulation. Feathers also served display purposes, attracting mates, warning rivals, or identifying individuals within herds or flocks. Think about peacocks, parrots, or birds of paradise today. Feathers are not just functional. They're fashion statements backed by millions of years of evolutionary selection. And now, we get to the colors. For decades, nobody knew what color dinosaurs were. The assumption was safe: drab, dull, camouflaged. But with the discovery of fossilized feathers came a new scientific frontier: melanosome analysis. Melanosomes are tiny structures in cells that hold pigment. Different shapes mean different colors: rods for black, spheres for red, and combinations for iridescent hues like blue and green. Under powerful microscopes, scientists examined the feathers of ancient dinosaurs and compared their melanosomes to those of modern birds. The results? Mind-blowing. Anchiornis had a gray and black body, a white striped tail, and a bright red crest on its head. Microraptor was likely glossy black, with iridescent feathers like a crow or raven. These weren't dull creatures skulking through the mud. They were vibrant, complex, and visually expressive. And feathers weren't exclusive to predators. Even some herbivores, like certain species of ornithischians, may have had filament-like structures, similar to early feathers. That opens up a whole new question. Was feathering more widespread than we thought? Now let's address the skin. Yes, many dinosaurs had scales too. Sauropods, ceratopsians, like Triceratops, and ankylosaurs were predominantly scaled, and fossilized skin impressions confirm that. These scales weren't uniform. Some had knobs, bumps, and even patterns, perhaps for display or thermoregulation. In fact, the skin of Hadrosaurus, a duck-billed dinosaur, has been preserved in exquisite detail, showing a complex pattern of scales arranged like mosaic tiles. Some even had quill-like structures on their tails, possibly primitive feathers. Possibly something else entirely. But here's the big takeaway. The image of dinosaurs as uniformly green, brown, or gray is a lazy guess. The reality? Dinosaurs likely came in every shade you can imagine: red, orange, blue, patterned, spotted, striped, or completely camouflaged depending on environment and behavior. Some could have changed color with age or mood, like modern reptiles and birds. Others may have displayed sexual dimorphism, where males and females look dramatically different, with the males sporting brighter colors for mating. In other words, your childhood toys? Probably all wrong. Now let's talk about feathers. And the path to flight. Feathers didn't evolve for flying. But once they existed, evolution took advantage. Enter Archaeopteryx, the most famous missing link between dinosaurs and birds. It lived around 150 million years ago, had fully formed wings, flight feathers, a wishbone, and a long bony tail. A mashup of bird and dinosaur. Could it fly? Probably yes, though not like a modern bird. Its bones were still relatively heavy, and its flight style may have been more like gliding or flapping short distances, but it was proof of concept. From there, evolution fine-tuned the formula, reducing tails, fusing bones, lightening skeletons, until the line between bird and dinosaur disappeared entirely. And here's the kicker: birds are dinosaurs. That's not poetic license. It's biological fact. Birds are the direct descendants of theropod dinosaurs, the same group that includes Velociraptor and T-Rex. Their skeletons are nearly identical in key places: hips, shoulders, feet, and skull structure. Modern birds even sleep with their heads tucked under a wing, just like fossilized raptors found in sleeping positions. Birds build nests, lay eggs, sing songs, and perform mating dances, all behaviors we now trace back to their dinosaur ancestors. That robin outside your window? It's wearing the same evolutionary badge as a creature that once roamed the same Earth as a 70-ton sauropod. And that brings us to an important truth. Dinosaurs never really went extinct. Sure, the non-avian dinosaurs were wiped out in the Great Extinction event, but their lineage survived, evolved, adapted. Every chirp, every flap of a wing, every nest of hatchlings, it's the continuation of a legacy 200 million years old. So what does this all mean for how we view dinosaurs? It means they were not lizards. They were not giant reptiles stomping aimlessly through swamps. They were active, feathered, vocal, intelligent, social, and possibly even beautiful in ways we're only beginning to understand. The next time you see a bird take flight, whether it's a hummingbird hovering or an eagle soaring, remember that you're witnessing a piece of Earth's greatest evolutionary success story. Feathers weren't just about flight. They were about expression, communication, survival, identity, and they were never just for show. They were power. And in the world of the dinosaurs, power came in many forms, not just brute strength, but in color, in display, in flight, and in feathers. Chapter 6. T-Rex and the kings of the Cretaceous. When it comes to dinosaurs, Tyrannosaurus rex stands alone in the popular imagination, the apex of apex predators, the heavyweight champion of prehistoric Earth. Its name literally means tyrant lizard king, and let's be honest, it earned that title. With bone-crushing jaws, a towering frame, and a reputation that even 65 million years of extinction hasn't dimmed. T-Rex is more than a dinosaur. It's a cultural icon. But here's the thing. T-Rex was just one of many fearsome predators. In the Cretaceous, this era, the last period of the dinosaur age, wasn't just about one king. It was a battlefield of giants. A savage, diverse, and complex ecosystem where carnivores competed, adapted, and evolved into some of the deadliest animals Earth has ever seen. Let's start with the main event. Tyrannosaurus rex, the last giant T-Rex lived in what is now North America around 68 to 66 million years ago, during the very end of the Cretaceous period. At nearly 40 feet long, standing 12 feet at the hip, and weighing up to 10 tons, it wasn't the longest or tallest dinosaur, but it was certainly one of the most powerful. Its skull alone could reach 5 feet in length, packed with teeth, the size of bananas, not slicing teeth like a shark, but thick, serrated, crushing weapons, designed not just to tear flesh but to pulverize bone. How powerful was its bite? Estimates put it at over 12,000 pounds of force, the strongest known bite force of any land animal in Earth's history. That's enough to crush a car like a soda can. But T-Rex wasn't all muscle and teeth. It had binocular vision, allowing it to focus on prey with depth perception, rare among dinosaurs. Its olfactory bulbs, the part of the brain responsible for smell, were enormous, suggesting it could track prey over miles, perhaps even days. Despite the myths, T-Rex wasn't a mindless brute. Its brain was proportionally large for a dinosaur, and its inner ear structure suggests it had excellent hearing, tuned especially to low-frequency sounds, perfect for detecting distant footsteps or deep, resonant calls. Still, for all its terrifying features, T-Rex wasn't alone, not even close. Let's meet some of the other kings of the Cretaceous, who rivaled or even outclassed T-Rex in their own way. Spinosaurus, the river monster. If T-Rex was the king of land, Spinosaurus was the lord of the rivers. At over 50 feet long and weighing an estimated 7 to 9 tons, Spinosaurus may have been the largest carnivorous dinosaur ever discovered. But its body was unlike any other. Spinosaurus had a long, crocodile-like snout filled with conical teeth, perfect for catching fish. Its nostrils were placed far back on its skull, allowing it to breathe while most of its head remained submerged. It had short, stocky hind legs, possibly webbed feet, and a long, fin-like tail, suggesting it was a strong swimmer. In 2014, and again in 2020, fossil discoveries in Morocco confirmed it. Spinosaurus was semi-aquatic, the first known swimming dinosaur. It likely hunted in deep river systems and coastal estuaries, ambushing large fish and marine reptiles. And that sail? The iconic spine rising from its back? Theories abound. It could have been used for temperature regulation, mating displays, or even storing fat. Some paleontologists think it might have helped the animal appear larger and more threatening, especially when confronting rivals or predators. But make no mistake, Spinosaurus wasn't a direct competitor to T-Rex. They lived on different continents, in very different environments. If they had ever met, it would have been a clash of styles, brute strength versus aquatic stealth. Giganotosaurus, the southern giant discovered in Argentina. Giganotosaurus, meaning giant southern lizard, was another massive carnivore, slightly longer than T-Rex, though more lightly built. It lived around 98 million years ago, during the mid-Cretaceous. Giganotosaurus didn't have the crushing bite of a T-Rex, but its skull was long and narrow, filled with sharp slicing teeth, better suited for slashing flesh than breaking bone. Scientists believe it hunted large sauropods, like Argentinosaurus, and may have done so in groups. Fossils of multiple individuals found in the same area suggest social or pack-like behavior, although that theory is still debated. Unlike T-Rex's vertical stance, Giganotosaurus had a more horizontal build, balanced by a long tail, built for speed, not power. Think of it as a Cretaceous cheetah, big, fast, and lethal. Carcharodontosaurus, the shark-toothed beast, another African predator. Carcharodontosaurus, named after the great white shark genus Carcharodon, was a close relative of Giganotosaurus. It had some of the longest skulls of any carnivorous dinosaur, measuring over 5.3 feet. It wasn't just big. It was beautifully designed for killing. Its teeth were serrated like steak knives, designed to tear flesh from even the largest prey. Like Spinosaurus, it roamed what's now northern Africa, sharing the ecosystem with other large predators. How did so many apex predators coexist? Likely by specializing, each hunting different prey or occupying slightly different ecological niches. Albertosaurus and Daspletosaurus, the tyrant cousins back in North America. Long before T-Rex showed up, there were other tyrannosaurs ruling the land, like Albertosaurus and Daspletosaurus. These were smaller cousins of T-Rex, but they had many of the same features: sharp teeth, powerful legs, tiny but muscular arms. They were faster, more agile, and likely pack hunters. One fossil site revealed a bone bed with over 20 Albertosaurus individuals, suggesting that they may have lived and hunted together, making them one of the few dinosaurs with possible evidence of complex social behavior. Imagine a pack of 20-foot-long predators coordinating a takedown. It's a chilling thought. Predator versus predator. Did they fight? One of the most exciting questions in paleontology is, did these massive carnivores fight each other? While most of them lived in different regions or eras, we do have fossil evidence of intraspecific combat. Predators fighting among their own kind. T-Rex skulls have been found with healed bite marks, suggesting violent fights between individuals. One fossil even shows a T-Rex with a bite to the face, strong enough to crush bone. But the wound healed, meaning it survived the encounter. Whether it was over territory, mates, or dominance, these confrontations were likely brutal and frequent. Beyond the kill, intelligence and behavior, these kings of the Cretaceous weren't just savage brutes. Many of them showed signs of advanced behavior, possibly even intelligence. T-Rex, for instance, had a large brain-to-body ratio among dinosaurs. It may have been capable of problem-solving, learning, and strategic hunting. Its large nasal cavity and complex inner ear suggest it was finely tuned to its environment, tracking scent, picking up vibrations, and possibly even communicating with deep, resonant vocalizations. We may never hear a T-Rex roar, but we now believe their sounds were like lions or bears, but more like low rumbles, booms, or infrasound calls, similar to elephants or crocodiles. Other predators, like dromaeosaurs, raptor-like dinosaurs, likely hunted in packs, used tactical ambushes, and had excellent vision and coordination. Were not talking Jurassic masterminds, but these weren't dumb lizards. They were apex predators because they were adaptable, aware, and efficient. The end of the reign of these kings was long, but not eternal, around 66 million years ago. A cataclysmic event brought it all crashing down, an asteroid impact near what is now the Yucatan Peninsula. We'll dive deep into that story in the next chapter, but before they vanished, the kings of the Cretaceous-shaped ecosystems controlled prey populations and left a legacy carved in rock. Their bones tell stories of power, conflict, and survival. On the edge, they were the peak of dinosaur evolution, not just in size, but in specialization, behavior, and dominance. And their stories are far from over, because every time we dig into the earth, every time we discover a new fossil, every time we run another scan or test another theory, they roar back to life. Chapter 7. Ocean monsters and sky tyrants. Long before mammals rose and cities were built, Earth was ruled not only by giants on land, but by astonishing creatures that ruled the oceans and soared across ancient skies. While dinosaurs stalked forests and plains, the seas churned with predators longer than buses, and the skies belonged to flying reptiles that could eclipse today's small planes with the span of their wings. These were not dinosaurs, technically speaking, but they lived side by side with them, sometimes hunting them, sometimes fleeing from them, and always shaping the balance of prehistoric ecosystems in ways more dramatic than we've ever fully understood. Beneath the surface of warm, shallow Cretaceous seas, predators like the mosasaurs glided through the water with terrifying grace. These marine reptiles were the unchallenged apex predators of their time. One, named Mosasaurus, could grow over 50 feet long, with a thick torpedo-shaped body, 2 rows of sharp teeth, and double-jointed jaws that allowed it to dislocate its mouth and swallow prey whole, like snakes. Its limbs had evolved into strong, paddle-like flippers, and its tail moved in powerful up and down strokes, more like a shark than a lizard. It was a killer of fish, turtles, other reptiles, and even its own kind. Some fossilized stomachs show the remains of smaller mosasaurs inside. And despite being an ocean dweller, this was no sluggish bottom feeder. With large eyes adapted for vision in dim, murky water and a highly sensitive snout, it was a precision hunter. It didn't chase, it waited, watched, and struck like a missile. But even before mosasaurs ruled, the oceans were already deadly. Millions of years earlier, they belonged to the plesiosaurs, creatures that looked like something from a myth. Some had long necks and small heads, like Elasmosaurus, which had a neck nearly 20 feet long, longer than its body. It may have used that snake-like neck to sneak up on fish without alerting them to its bulk. Others, like the pliosaurs, flipped the formula: short necks, enormous jaws, and terrifying bite force. Kronosaurus was one such beast, with a skull that stretched over 9 feet, filled with teeth that could crush bone and armor alike. It didn't just eat, it demolished. In these ancient oceans, even breathing at the wrong time could mean death from below. Then came the ichthyosaurs, reptilian dolphins with gigantic eyes, some species reaching lengths of over 70 feet. Sleek, fast, and built for deep diving, they were among the earliest marine reptiles to dominate the Triassic oceans. Their evolution was so advanced that they gave birth to live young, with fossils frozen in time showing mothers in the process of delivering a baby tail first, just like modern whales. Their flippers were incredibly efficient, their tails crescent-shaped, and their eyes adapted to detect motion in the blackest depths. They likely hunted squid, ammonites, and anything else small enough to snatch from the abyss. Ocean life during the age of dinosaurs wasn't peaceful. It was brutal, fast-paced, and unforgiving. Marine reptiles weren't just surviving, they were innovating. Some evolved body armor, like the placodonts. Others had long needle-like snouts to snatch slippery prey. A few may have used suction to vacuum up shellfish. But it was the predators that defined the rhythm of the sea, and their reign lasted tens of millions of years. Fossils from ancient seabeds in Germany and England preserved in limestone, so fine it captured even skin texture, have given us glimpses into their anatomy, their diets, and even their last meals. And just when you thought things couldn't get more dramatic, you look up. Because while the oceans were deadly, the skies were ruled by creatures so large and so unlike anything flying today. They still baffle scientists. The pterosaurs were the first vertebrates to achieve powered flight, long before birds. Some had wingspans of only a few feet and probably spent their lives gliding through forests, hunting insects and fish. Others were enormous. Quetzalcoatlus, the largest known flying animal in Earth's history, had a wingspan that stretched nearly 40 feet. As tall as a giraffe on land, with a beak like a spear and a lightweight, hollow-boned skeleton. It likely launched itself into the air, using all 4 limbs, vaulting itself skyward before gliding for miles. Its flight wasn't flapping like a bird's, it was soaring, catching thermals, drifting for hours across prehistoric landscapes, scanning for food or carrion. Pteros, a URS, weren't just one type of animal. They came in hundreds of forms. Some had crests taller than their skulls. Some had teeth like needles. Others were toothless and beaked. Some specialized in fish. Others may have eaten fruit or small vertebrates. One pterodastro had a curved beak lined with bristle-like teeth and likely fed like a flamingo, filtering plankton from shallow waters. Their wings weren't like birds. They were membranes, stretching from an elongated finger down to their ankles or hips. It made them incredibly maneuverable, but also fragile. Their bones were paper-thin and easily crushed. Yet despite this, they dominated the skies for more than 150 million years. Their competition eventually came from their own evolutionary cousins, birds. But the early birds were no match for the massive pterosaurs, at least not yet. For millions of years, birds stayed small, tree-bound, or ground-dwelling. Meanwhile, the skies above the Cretaceous forests belonged to winged giants. You could walk for miles in a dense jungle and see no sign of a pterosaur, but high above, drifting on the thermals, they watched, waiting, hunting, or just surviving the only way they knew how, through flight. And in the middle of all this, land, sea, and air was the balance of ecosystems we're only beginning to understand. What happened in the oceans affected the coasts. What dominated the skies shaped the behavior of prey below. Everything was connected. There were no empty spaces. Evolution had filled every niche dot until slowly the world began to change. Sea levels rose and fell. Volcanic activity heated the planet, then darkened the sky. Continents drifted apart, isolating populations and driving new adaptations. And in this period of geological chaos, even the rulers began to struggle. The giant ichthyosaurs began to disappear, replaced by more efficient hunters. The plesiosaurs fell into decline. Even the mighty mosasaurs and pterosaurs were facing pressures, competition, changing habitats, and possibly dwindling prey. They had ruled for so long, but the world they mastered was turning against them, and then it ended. The skies went dark, but that's not the story for today. That cataclysm, the one that brought it all crashing down, comes next, because before the fire fell from the heavens, Before ash rained across continents and tsunamis swallowed coastlines, there was a final age of glory. One last chapter where ocean monsters still hunted, sky tyrants still soared, and the earth still belonged to ancient giants, a world alive with color, movement, sound, and power. And in the silence of their bones, they left behind a warning that even the rulers of earth are temporary. And that the ocean and sky forget nothing. Chapter 8. The Day the Sky Fell. The end of the dinosaur 66 million years ago. It was just another day. The sun rose over dense Cretaceous jungles, casting shadows across ferns and flowers that had never felt winter. Insects buzzed. Herds of horned dinosaurs moved through open plains. Pterosaurs soared above coastal cliffs. In the forests, predators stalked. Oceans lapped gently at the shores, unaware. Everything was as it had been for millions of years. Then, in the blink of a geological eye, it was over. The object that changed everything was roughly the size of a city, about 6 to 10 miles wide, but it was traveling at over 40,000 miles per hour. Faster than sound, faster than thought, it tore through space and slammed into the earth with a force over 2 million times greater than the most powerful nuclear bomb ever detonated. It struck the shallow sea near what is now the Yucatan Peninsula in Mexico. That point of contact became the Chicxulub crater, a scar on the earth that measures nearly 100 miles across. For the dinosaurs, there was no warning. There were no words. Just light, and then fire. A blinding explosion erupted across the sky, turning air itself into flame. Trees ignited. Winds roared at thousands of miles per hour. Everything within 1,000 miles of the impact was vaporized instantly. The earth shook. Massive earthquakes and volcanic eruptions rippled across continents. The sea rushed inland, towering tsunamis swallowing coastlines and dragging forests out to sea. But that was just the beginning. The real extinction unfolded in the hours, days, and months that followed. The impact hurled trillions of tons of rock and vaporized sulfur into the atmosphere. Superheated debris rained back down, igniting global wildfires. The sky glowed red. Across the planet, day turned to night. The sun disappeared behind a thick, choking haze. Global temperatures dropped drastically. Photosynthesis stalled. Plants withered. The food chain collapsed from the bottom up. In oceans, plankton died first. On land, it was the leaves, the seeds, the flowers. Then came the herbivores, starving, disoriented, exposed. Then the predators. It took only a few months for ecosystems that had lasted for 150 million years to unravel. The Earth didn't just suffer an extinction. It experienced a biological reset. Around 75% of all species on Earth vanished, including every non-avian dinosaur. The mighty Tyrannosaurus rex, gone. The horned Triceratops, gone. The long-necked titanosaurs, the duck-billed hadrosaurs, the armored ankylosaurs, all gone. On the seas, the mosasaurs and plesiosaurs vanished. In the skies, the last of the giant pterosaurs fell. This wasn't just the end of a few animals. It was the closing of an entire chapter in Earth's biological history. And yet, not everything died. Some creatures survived. Birds, for one. The small, feathered descendants of theropod dinosaurs weathered the storm. How? Maybe because they were small. Maybe because they could eat seeds and insects. Maybe because they nested in burrows or forests, or were just lucky. Whatever the reason, they made it through. And so did some mammals, turtles, crocodiles, and certain amphibians. In the ashes of the old world, these survivors crawled forward, blinking into a changed Earth. For years after the impact, Earth was a planet in mourning. The skies remained dark. The air was cold and bitter. Rain was acidic. Landscapes were stripped bare. Volcanoes may have continued to erupt in India, releasing even more gas into the atmosphere. The planet's climate shifted violently. It was Not a place for giants anymore. The age of the dinosaurs had ended. But let's be clear, the asteroid wasn't the only reason. Earth was already under stress. Sea levels were changing. The continents were drifting apart. Volcanic activity was high. Some species were already struggling. But the asteroid was the final blow, the knockout punch. It didn't just hit the planet. It rewrote its destiny. For decades, the idea of an asteroid killing the dinosaurs was controversial. It seemed too simple, too sudden. But then, in the 1980s, scientists Luis and Walter Alvarez discovered a thin layer of iridium-rich clay all over the world, an element rare on Earth but common in asteroids. That layer, called the KPG boundary, was the fingerprint of impact. It was found in rock strata across every continent. In 1991, the Chicxulub crater was identified, proof that the impact happened where, when, and how the evidence had long hinted. And in that moment, science had its smoking gun. It's a strange thing to think about. The end of the dinosaurs wasn't a battle, or a disease, or a slow fade. It was a rock, a random event, a piece of cosmic debris that struck at exactly the wrong time, in exactly the wrong place, with exactly the right force to undo a world. And yet, the story didn't really end, because in the silence that followed, life didn't give up. It adapted. The mammals began to rise. Birds spread across the globe. Ecosystems reshaped themselves. The trees grew again. The oceans refilled with different creatures. A new world emerged, not better, not worse, just different. We often think of the asteroid as a tragedy, and it was. But it was also a turning point. If it hadn't happened, the dinosaurs might still rule today. Mammals might never have taken over. Humans might never have evolved. Our story, as we know it, is built on the ashes of theirs. It's humbling to realize that the creatures who lived longer than any species today, who adapted to every climate, who survived countless disasters, could still be swept away by chance. That even the strongest aren't immune to the randomness of the universe. But maybe that's the lesson. That nothing lasts forever, that no kingdom is permanent, that the world changes and those who change with it survive. The dinosaurs weren't weak, they were extraordinary. But fate doesn't reward strength alone. And yet, in a way, they never left us. Every bird in the sky carries their genes. Every fossil in stone carries their memory. And in our imaginations, they walk still through forests, across plains, beneath stars that watch them rise and watch them fall. We don't just study dinosaurs because they were massive or monstrous. We study them because they remind us how fragile life is, how short each chapter can be, and how beautiful it is that even after death, their story can still shape ours. Their extinction wasn't the end. It was the beginning of a new world. And in the next chapter, we'll meet the creatures who inherited that world, not the ones who vanished, but the ones who endured, the ones who survived. Chapter 9, the ones who survived after the fire and the ash, after the skies went dark and the forests burned. Earth was quiet, not peaceful, devastated. The once lush continents were stripped bare. The oceans churned with sediment and death, and across the world, silence replaced the roars and calls that had once echoed through the Cretaceous air. But even in that silence, life clung on. In burrows, beneath logs, deep in lakes and streams, in the shadows of extinction, some creatures survived. And they weren't the biggest or the fiercest or the fastest. They were the smallest, the most adaptable, the ones built to bend without breaking. This is their story, not of dominance, but of endurance. Not of ruling the earth, but of outlasting the rulers. Among the most surprising survivors were the birds. Not all of them, of course. Many early bird lineages perished with the dinosaurs. But a small, unremarkable group of ground-dwelling birds made it through. Likely no bigger than chickens, they didn't soar like pterosaurs or perch like songbirds. They ran, they foraged, They ate seeds, bugs, maybe even small animals. But more importantly, they were survivors of the theropod lineage, direct descendants of the raptors and feathered dinosaurs that once hunted beneath ancient canopies. When the asteroid struck, many animals died from the shockwave, the fire, the starvation that followed. But these birds, able to live off scraps, seeds, and insects, managed to endure. And from their lineage came the over 10,000 bird species we see today, from hummingbirds to ostriches, all carrying the DNA of ancient beasts. In a way, the birds didn't just survive the extinction. They inherited the sky, but birds weren't alone. Mammals, too, emerged blinking into the dim post-impact light. Throughout the Mesozoic, mammals had lived in the shadows, literally. Most were nocturnal, small, insectivorous. They avoided the dinosaurs rather than compete with them. But when the dominant predators and herbivores were wiped out, mammals didn't just survive, they exploded in diversity. Within a few million years, mammals were spreading across every continent, evolving into hundreds of new forms. Some returned to the water, others took to the trees. Some grew horns, some hooves, some long grasping fingers. Among them were our own ancestors, small, primate-like creatures clinging to branches in the recovering forests, watching the rebirth of the world. Without the extinction, mammals may have remained small, marginal, forever outcompeted by dinosaurs, but the opening left behind gave them space to rise, to expand, to evolve, and it wasn't just mammals and birds. Reptiles like crocodiles and turtles, which had already survived multiple extinctions, once again made it through. Crocodiles are particularly fascinating. Apex predators that had shared the world with dinosaurs, even hunted some of them, and yet remained unchanged for tens of millions of years. Their secret? A slow metabolism. The ability to go months without eating. A tendency to lay low, conserve energy, and outwait disaster. Today's crocodiles are living fossils, almost identical to their ancient ancestors. And that's not a sign of stagnation. It's a mark of perfection. When nature gets it right, she doesn't need to change it. Turtles, too, carried on. Aquatic, slow-moving, shell-armored, their design offered protection and endurance. Some species of soft-shelled turtles today still bear similarities to forms that existed in the Cretaceous. Amphibians, hiding in mud, surviving in moisture-rich environments, also made it through. Their skin, sensitive to change, helped them react to new climates, and their short lifespans allowed for fast adaptation over generations. Fish, insects, plants, many of these ecosystems collapsed but quickly rebalanced. In the oceans, plankton populations eventually recovered. Coral reefs were decimated, but slowly rebuilt by new reef builders. Sharks, rays, and bony fish diversified. Some lineages went extinct, but others quickly took their place. On land, ferns were the first to return, their spores capable of traveling and growing even in harsh conditions. Then came fast-growing flowering plants, grasses, trees. And with the plants came herbivores, and with herbivores, predators. The wheel turned again. It's easy to look at survival and think of it as luck, and sometimes it is. But survival also comes from being prepared for a world that doesn't exist yet. Creatures that could handle scarcity, that weren't tied to specific diets, that could hide or migrate or hibernate. These were the ones who made it. They didn't fight extinction. They waited it out. Evolution doesn't always reward power. It often rewards patience. And while the age of the dinosaurs ended in fire and silence, the age of mammals began in quiet growth. Within 10 million years, we had dog-sized predators, hoofed runners, early bats flapping through night skies. Mammals filled niches left empty, growing larger, smarter, more social. The planet was still healing, but life was quick to return. Earth, after all, doesn't stay empty for long. But perhaps the most poetic part of this chapter isn't just that life came back. It's how it carried the past forward. Birds inherited the bones and lungs and feathers of their dinosaur ancestors. Crocodiles kept their ambush tactics and armored hides. Mammals, in their tiny brains, carried the seeds of thought, of curiosity, of future understanding. The world didn't forget the dinosaurs, it built on them, carried pieces of them into the future, recycled their legacy into the next great experiment. Today, we walk among the descendants of survivors. Every bird in the sky is a reminder of those that fell and those that flew. Every mammal on land, from whales to humans, owes its place to a gap left by extinction. And deep in the DNA of every living thing are echoes of that day when the sky fell, and only a few made it through. The ones who survived weren't the biggest. They weren't the loudest. But they were the ones that bent, shifted, endured. They were the seed in the ash, the heartbeat in the silence, the last breath before the new world began. And because of them, the story didn't end, it only changed course. Chapter 10. When the world was quiet again, after the sky fell and the fire faded, the world was still. Not peaceful, not yet, but still. The chaos that had ripped through the planet left behind more than just silence. It left space, emptiness, a vacuum of life, power, and presence. For the first time in over 150 million years, Earth no longer belonged to the dinosaurs. And in the eerie calm that followed, a different kind of movement began, slower, more careful, driven not by dominance, but by quiet resilience. It was the beginning of something new, not because it was louder or stronger, but because it grew in the cracks left behind. Picture the landscape. Ash still clings to the soil, sunlight finally filtering weakly through a hazy sky, where once there were lush forests, now stand skeletal trees, scorched stumps, or nothing at all. The air is cooler, drier. The wind carries no calls, no songs, just dust. But at ground level, life does what it always does. It begins again. Ferns were some of the first to reclaim the land, spreading quickly with spores that drifted through the air like fine ash. Fossil records show a strange abundance of ferns in layers just above the extinction boundary, a phenomenon scientists call a fern spike. It was Earth's first green breath after the disaster, a soft reminder that not all things need roots to survive. From these first plants came more grasses, shrubs, flowering species that had only recently begun to evolve before the asteroid hit. Now, in the absence of towering conifers and the browsing mouths of long-necked dinosaurs, these newer plants took hold, shaping ecosystems that no creature had yet imagined. With the plants came insects. Some had survived deep underground, others in eggs. Beetles, ants, flies, all tiny architects of decay and rebirth, returned in swarms, feeding on dead matter, pollinating early flowers, and laying the groundwork for a recovering biosphere. And where insects flourished, so too did the creatures that ate them. Small reptiles scurried through underbrush. Amphibians re-emerged from wetland burrows. Mammals, once limited to the night and the shadows, now explored freely under open skies. These early mammals weren't spectacular. They were shrew-like, mouse-like, little furred things with keen noses and sharp teeth. But they carried something precious: time. Time to evolve, adapt, and spread into forms the dinosaurs had once outcompeted. And slowly, over millions of years, they diversified. Some grew larger, some climbed, some hunted, some burrowed. They were not dominant, not yet, but they were everywhere. Birds, too, carved out their place. The great flying reptiles were gone, their once mighty wings reduced to bones in the dirt. But birds, small, feathered, flexible, continued the lineage of flight. Some lived like gulls or sandpipers, scavenging shorelines. Others nested in trees, which had returned in patches across the continents. Their songs, tentative at first, would eventually fill forests that had once echoed with the growls of predators. And though they bore the bloodline of raptors, Their survival depended not on violence, but on caution, cooperation, and adaptation. Even the oceans, disrupted by acid rain and dying plankton, began to stir again. With time, marine life rebounded. New species of fish appeared, some evolving into forms eerily similar to their ancient relatives. Sharks, always survivors, filled the predator void left by the mosasaurs. Coral reefs reassembled themselves, grain by grain, polyps rebuilding, over the shattered bones of their ancestors. Life in the sea had taken a hard blow, but as with land, it was never a question of whether life would return, but when and how. And through all this, Earth was changing. The continents drifted further apart, mountains rose, volcanoes shaped new islands. Climate fluctuated. Each shift brought new challenges, new opportunities. And the survivors, those quiet, overlooked species, took advantage of everyone. There was no single explosion of life, no overnight conquest. It was a steady pulse, a heartbeat, a slow, silent flood of diversity that reshaped the world in unfamiliar, fragile patterns. Millions of years passed. What had once been a blank slate began to resemble something wild and full again. Not the same, never the same, but alive in its own right. The age of dinosaurs was over. The age of mammals had begun. But traces of the past still lingered. In rocks, of course, where skeletons lay undisturbed until unearthed by future minds. In DNA, passed down through feathers, lungs, hips, and beaks. In ecosystems where predator and prey still play the ancient game. But also in the structure of the planet itself, landscapes carved by extinct feet, sediments shaped by vanished, migrations and soils fertilized by the final breaths of giants. The world carried their memory not in monuments, but in function. And there were mysteries too, questions left behind, fossils missing, stories unfinished. Species that vanished without explanation, evolutionary branches that led nowhere, behaviors hinted at in bone, but never confirmed. For every answer unearthed, another 10 appeared, whispering of a world we can only partially know. The silence after the extinction was not just absence, it was complexity waiting to return, because survival is never just about staying alive. It's about adapting fast enough to make something new. And those early survivors, humble as they were, began to rebuild not only food chains and habitats, but possibilities. They unlocked futures that even the dinosaurs, in all their glory, never reached. Futures that included us. And now, millions of years later, we walk the same ground. We breathe the same air. We swim in oceans that once boiled with giants. We look up at birds and see something ancient in their bones. The world that was quiet once sings again, not with the same voices, but with new ones, shaped by survival, written by time, and echoing a truth deeper than extinction, that life does not surrender. It transforms. Chapter 11 whispers in the stone beneath our cities, under our forests, beneath deserts and mountaintops, locked inside the earth itself, lie voices. Not ones we can hear with ears, but voices all the same, whispers of a world before ours, frozen in stone, waiting to be read like a memory etched in the planet's bones. Every fossil ever found is a sentence in that forgotten language, every skeleton, a paragraph, and every layer of rock, a chapter in the biography of life itself. We are not the first to walk this world. And deep down, beneath our feet, the past still speaks. For centuries, we didn't know how to listen. Ancient peoples found fossils and wondered if they were the bones of giants or dragons or gods. And honestly, that wasn't far from the truth. It wasn't until the 19th century that science gave names to the bones, first iguanodon, then megalosaurus, and then the word that would capture the imagination of the world, dinosaur. From dinos, meaning terrible or wondrous, and sauros, meaning lizard, terrible lizard. But they weren't lizards. And they weren't just terrible. They were extraordinary. Once we began listening, we couldn't stop. Fossils don't just tell us what something looked like. They tell us how it moved, what it ate, how it died, and sometimes how it lived. A series of footprints across ancient mud can reveal a mother and her young walking together. A nest of eggs fossilized in sediment can hint at parental care. A tooth embedded in a bone can suggest a failed hunt or a battle between rivals. Even the way bones are broken, scattered, or fossilized together paints a picture of ancient behavior. In many ways, paleontology is not about bones. It's about story. And sometimes it's about mystery, because not every fossil fits the rules. Some are so strange they rewrite everything we thought we knew. A dinosaur with feathers before feathers were supposed to exist. A predator with fins. A herbivore with claws. Evolution didn't work in straight lines. It worked in sparks: trial, error, adaptation. And it left behind strange, beautiful evidence of what worked, what didn't, and what almost did. These discoveries don't just happen in the field, under the sun, pickaxe in hand. They happen in museum basements when forgotten bones are re-examined with new eyes. They happen in labs where CT scans reveal hidden structures inside ancient skulls. They happen when technology finally catches up to the questions we've been asking for 100 years. And every time we look deeper, the past reveals more of itself. Not just in what was, but in what could have been, because some fossils are windows, not just mirrors. When we look at the vertebrae of a sauropod, we see a structure designed to support a neck longer than a bus, but we also see the physics of balance, the limits of weight, the marvel of internal air sacs that made the impossible possible. When we analyze the feathers of a theropod, we learn not only about color or heat regulation, but about communication, attraction, and the long, winding road to flight. Fossils teach us biology, yes, but also design, resilience, and creativity. Nature, it turns out, was the first and greatest engineer, and sometimes fossils show us ourselves, not literally, of course, but in the quiet, persistent threat of survival. In how life adapts, branches out, dies back, and rises again. In the way ecosystems rebuild, in the way traits evolve, in the persistence of behavior across millions of years. The curiosity of a bird is not so different from the cleverness of a small raptor. The social bonds of a herd of elephants echo the protective instincts of a nesting hadrosaur. The architecture of a beehive carries the same urgency as a Cretaceous forest alive with insects. We are not apart from that story. We are a continuation of it. And the earth remembers. There are places where ancient bones lie, just inches beneath your feet, where cliffs are made of sediment once settled in ancient seas, where rivers still follow the paths carved by vanished floods. Every landscape holds a deeper history. Every stone has the potential to carry a fragment of a world we'll never fully understand, but can still touch. Still hear if we listen closely enough. And sometimes, what we hear is haunting. There are mass graves in the fossil record sites, where dozens of individuals died together, trapped in mudflows, drowned in floods, or buried by volcanic ash. In Montana, in Mongolia, in Argentina, we found whole communities fossilized midlife. Dinosaurs locked in combat, parents curled around eggs, predators mid-pounce. These are not just skeletons. They are moments, preserved emotion, frozen, struggle. And when we study them, we're not just learning what happened, we're feeling it. Fossils are empathy across time, and that connection matters more than ever now, because we live in a time when extinctions still happen, when ecosystems still collapse, when species vanish not from asteroids but from us, from how we shape the earth, consume it, burn it. The difference is, we know better. The dinosaurs had no warning, we do. And the fossils remind us what's at stake, not just scientifically, but spiritually. They are records, yes, but also warnings, not of doom, but of consequence. Nature will go on. Life will adapt. But what form will it take if we're not careful? In this way, the whispers in stone are more than echoes. They're teachers. They remind us that the world has changed before, will change again, and that we are part of that change whether we want to be or not. And they give us hope too. Because after every extinction came rebirth. After every silence came song. The earth has never stopped creating, and it never will. And every fossil pulled from the ground is proof, not just of what we've lost, but of what is still possible. So the next time you hold a stone, or see a museum exhibit, or pass a cliff on the side of the highway, think of what lies beneath. The bones, the stories, the whispers. Because they're still there. Still speaking. And the story they tell isn't finished. Chapter 12. The shape of time. Time is invisible. You can't touch it. You can't hear it. And yet, everything you know, every moment you've lived, every breath you've taken, happened inside it. Time shapes mountains, grinds forests into coal, turns oceans into deserts, and back again. But nowhere is time more visible than in the story of the dinosaurs. Their rise, their rule, and their fall didn't happen in days or centuries. It happened over millions of years, like a painting so vast we can only see small pieces of it at once. And yet, when we study their bones, trace their migrations, and decode their biology, what we're really doing is learning to see time itself. When the first dinosaurs appeared over 230 million years ago, the Earth was one giant continent, Pangaea. Stretched across the globe, a supercontinent surrounded by a single ocean. But the land was restless. Tectonic plates shifted, cracked, and broke apart over millions of years, slowly dragging entire land masses across the planet like floating rafts. As Pangaea split, dinosaurs went with it. Some traveled with South America, others with Africa or Asia. Isolated by distance, climates, and evolving environments, they diversified. That's why we find vastly different dinosaur species on different continents. Not because they couldn't travel, but because time moved the land beneath them. In Argentina, the massive sauropods evolved to graze open plains. In Mongolia, nimble raptors stalked the dunes of what was once a lush floodplain. In North America, horned dinosaurs formed vast herds across what would become the Western Interior Seaway. And in each of these places, evolution followed its own tempo, its own experiments. Some species thrived for tens of millions of years. Others disappeared almost as soon as they arrived. The fossil record doesn't show one single story, it shows 1,000 overlapping timelines, each one shaped by time, geography, and chance. And chance played a bigger role than we like to admit. Take the fossilization process itself. Not every animal becomes a fossil. In fact, almost none do. Most creatures die and are quickly consumed, decomposed, scattered by scavengers, or lost to weather. To become fossilized, an animal usually had to die in just the right way, in a riverbed, or in ash, or under mud, then be quickly buried before decay could erase it. The conditions had to be perfect. The mineral-rich water, the pressure, the layers of sediment, millions of years of chemistry just to preserve a single skeleton. That's why every fossil we find is a miracle. Not because it's rare, but because it's even there at all. And when we hold that fossil, we're not just holding bone, we're holding time, compressed, captured, waiting. We tend to think of time as a straight line, past, present, future. But the dinosaurs show us that time isn't straight. It loops, it folds, it echoes. You can find rocks in Utah that are older than trees, or stand in a desert in Morocco and hold a tooth older than flowers. The earth doesn't organize time like we do. Its memory is layered one on top of the other, mud over bones, over ash over stone. And each layer tells a story. You just have to know how to read it. Sometimes you find whole environments fossilized together, Not just bones, but footprints, leaves, pollen, even raindrops petrified in stone. These are called Lagerstätten, mother lodes of preservation. They're rare, but when found, they're like photographs of time. The fish that died mid-swim, the insects caught mid-flight, the mammals curled around their young. These moments, suspended for millions of years, are time's way of showing us what it really looked like. And then there are mass extinctions, the punctuation marks in Earth's long sentence. The dinosaurs were shaped by at least two of them. The first opened the door for their rise. The second ended their reign. But between those events, time wasn't empty. It was filled with slow shifts, climates changing, ecosystems evolving, new species appearing while old ones quietly faded. The world of a Jurassic Brachiosaurus was radically different from that of a late Cretaceous Triceratops. Different plants, different insects, different skies. We lump them together as dinosaurs, but the time between those two species is longer than the time between us and the last. Mammoths. And maybe that's what makes the dinosaur story so powerful. It forces us to think beyond human time, beyond clocks and calendars. It asks us to imagine a scale so vast that a million years becomes a footnote, that civilizations are flickers, that entire species can rise, rule, and vanish in the space between one heartbeat of the planet and the next. That's a hard perspective to hold. We live in the now, in the short term, in seconds and likes and deadlines. But when you look at a fossil, you're reminded that everything we know is temporary, and that's not a reason for despair. It's a reason to care, to pay attention, to respect the fragile span we're given. The dinosaurs ruled for over 160 million years. Humans have been here for maybe 300,000. If time is a book, we're still on the first sentence of our chapter. And yet, the dinosaurs aren't gone, not entirely. Their bones teach us. Their descendants fly around us. Their story, layered in the earth, continues to be written by every paleontologist, every child digging in dirt, every person who stops to wonder. In a way, time didn't erase them, it recorded them. So we could find them again. There's something deeply human in that. The need to understand what came before. The need to reach back through the dark and touch something ancient. Maybe that's why we love dinosaurs, not just for their size or their power, but because they remind us we're part of something bigger. A world older than we can grasp. A history longer than we can imagine. And a future we still have a chance to shape, because time isn't just behind us. It's ahead of us too. And what we do with it matters. Chapter 12, The Shape of Time. Time is invisible. You can't touch it. You can't hear it. And yet, everything you know, every moment you've lived, every breath you've taken happened inside it. Time shapes mountains, grinds forests into coal, turns oceans into deserts, and back again. But nowhere is time more visible than in the story of the dinosaurs. Their rise, their rule, and their fall didn't happen in days or centuries. It happened over millions of years, like a painting so vast we can only see small pieces of it at once. And yet, when we study their bones, trace their migrations, and decode their biology, what we're really doing is learning to see time itself. When the first dinosaurs appeared over 230 million years ago, the Earth was one giant continent, Pangaea, stretched across the globe, a supercontinent surrounded by a single ocean. But the land was restless. Tectonic plates shifted, cracked, and broke apart over millions of years, slowly dragging entire land masses across the planet like floating rafts. As Pangaea split, dinosaurs went with it. Some traveled with South America, others with Africa or Asia. Isolated by distance, climates, and evolving environments, they diversified. That's why we find vastly different dinosaur species on different continents. Not because they couldn't travel, but because time moved the land beneath them. In Argentina, the massive sauropods evolved to graze open plains. In Mongolia, nimble raptors stalked the dunes of what was once a lush floodplain. In North America, horned dinosaurs formed vast herds across what would become the western interior seaway. And in each of these places, evolution followed its own tempo, its own experiments. Some species thrived for tens of millions of years. Others disappeared almost as soon as they arrived. The fossil record doesn't show one single story, it shows 1,000 overlapping timelines, each one shaped by time, geography, and chance. And chance played a bigger role than we like to admit. Take the fossilization process itself. Not every animal becomes a fossil. In fact, almost none do. Most creatures die and are quickly consumed, decomposed, scattered by scavengers, or lost to weather. To become fossilized, an animal usually had to die in just the right way, in a riverbed, or in ash, or under mud, then be quickly buried before decay could erase it. The conditions had to be perfect. The mineral-rich water, the pressure, the layers of sediment, millions of years of chemistry just to preserve a single skeleton. That's why every fossil we find is a miracle. Not because it's rare, but because it's even there at all. And when we hold that fossil, we're not just holding bone, we're holding time. Compressed, captured, waiting. We tend to think of time as a straight line, past, present, future. But the dinosaurs show us that time isn't straight. It loops, it folds, it echoes. You can find rocks in Utah that are older than trees, or stand in a desert in Morocco and hold a tooth older than flowers. The earth doesn't organize time like we do. Its memory is layered one on top of the other, mud over bones, over ash, over stone. And each layer tells a story. You just have to know how to read it. Sometimes you find whole environments fossilized together, not just bones, but footprints, leaves, pollen, even raindrops petrified in stone. These are called Lagerstätten, mother lodes of preservation. They're rare, but when found, they're like photographs of time. The fish that died mid-swim, the insects caught mid-flight, the mammals curled around their young. These moments, suspended for millions of years, are time's way of showing us what it really looked like. And then there are mass extinctions, the punctuation marks in Earth's long sentence. The dinosaurs were shaped by at least two of them. The first opened the door for their rise. The second ended their reign. But between those events, time wasn't empty. It was filled with slow shifts, climates changing, ecosystems evolving, new species appearing while old ones quietly faded. The world of a Jurassic Brachiosaurus was radically different from that of a late Cretaceous Triceratops. Different plants, different insects, different skies. We lump them together as dinosaurs, but the time between those two species is longer than the time between us and the last mammoths. And maybe that's what makes the dinosaur story so powerful. It forces us to think beyond human time, beyond clocks and calendars. It asks us to imagine a scale so vast that 1,000,000 years becomes a footnote, that civilizations are flickers, that entire species can rise, rule, and vanish in the space between one heartbeat of the planet and next. That's a hard perspective to hold. We live in the now, in the short term, in seconds and likes and deadlines. But when you look at a fossil, you're reminded that everything we know is temporary, and that's not a reason for despair. It's a reason to care, to pay attention, to respect the fragile span we're given. The dinosaurs ruled for over 160 million years. Humans have been here for maybe 300,000. If time is a book, we're still on the first sentence of our chapter. And yet, the dinosaurs aren't gone. Not entirely. Their bones teach us. Their descendants fly around us. Their story, layered in the earth, continues to be written by every paleontologist, every child digging in dirt, every person who stops to wonder. In a way, time didn't erase them, it recorded them. So we could find them again. There's something deeply human in that. The need to understand what came before. The need to reach back through the dark and touch something ancient. Maybe that's why we love dinosaurs, not just for their size or their power, but because they remind us we're part of something bigger. A world older than we can grasp. A history longer than we can imagine. And a future we still have a chance to shape, because time isn't just behind us. It's ahead of us too. And what we do with it matters. Chapter 13. What dinosaurs still teach us today. The dinosaurs are gone, but they never truly left. Their bones rest beneath our feet, their story lingers in stone and air, and their descendants sing above our cities each morning. They exist not just in museums, not just in science, but in the imagination of every child who's ever roared like a T-Rex or traced the spine of a plastic stegosaurus. They walk with us in our wonder, and though they vanished long before we arrived, they still have lessons to teach us about survival, power, loss, and the long, patient rhythm of life on Earth. They remind us that dominance is not the same as permanence. For over 160 million years, dinosaurs ruled. They evolved into every imaginable form: fast runners, slow grazers, armored tanks, clever hunters, gliders, swimmers, waders, wanderers. They adapted to supercontinents, split apart with drifting plates, lived through volcanic winters and oxygen swings, and thrived in ecosystems as varied as ice-free poles and humid swamps. They were, by every measure, Earth's most successful creatures. Until they weren't. A random collision, a 6-mile-wide asteroid moving faster than thought ended it, all in one terrible moment. Not because the dinosaurs did anything wrong, but because life on Earth is fragile, beautiful, temporary. The first lesson they offer us, then, is humility. No species, no matter how powerful, is guaranteed tomorrow. And no world, no matter how alive, is immune to sudden change. But the dinosaurs also teach us about resilience, about how life responds when everything is taken away. Because not all dinosaurs died. Some shrank, adapted, took to the trees, took to the air, and survived the firestorm. Today, every bird you see is proof of that resilience, a creature shaped by catastrophe, perfected by evolution, and still flying long after its cousins fell. When you see a sparrow land on a wire or a heron stalk a riverbank, you're not looking at something separate from the ancient past. You're looking at a lineage that endured one of the worst days in Earth's history and kept going. They teach us about change too, about how no world stays the same. The Earth of the Jurassic was not the Earth of the Cretaceous. Species came and went. Climates warmed and cooled. Forests became deserts. Rivers turned to rock. Dinosaurs didn't resist these changes. They evolved with them. They didn't cling to the past. They shaped the future. Our world today is changing fast: climate, oceans, extinction rates, and we'd be wise to remember what happens when species can't or won't adapt. They teach us about mystery. For all we've uncovered, thousands of fossils, millions of bones, we still know so little. New discoveries happen every year. Entire species, entire behaviors, entire ecosystems that we never dreamed existed. There are still unanswered questions about how they communicated, how they nested, what colors they were, how they felt pain, whether they were social, whether they mourned. Paleontology isn't about what we know, it's about what we keep discovering, and that means curiosity never dies. There is always more to learn. They teach us about perspective. Human history feels long, but in the context of deep time, we are a blink. Dinosaurs were here for 160 million years. That's 500 times longer than humans have existed. They survived longer than any empire, any language, any idea, and yet they still ended. When we talk about climate change or biodiversity loss today, we must think in that scale, not in decades, in centuries, in millennia. What we do now echoes across epochs. They teach us, strangely, about beauty. Because for all their size and strangeness, dinosaurs weren't monsters, they were alive. And their world was alive. There was elegance in the stretch of a sauropod's neck, in the feathers of a microraptor gliding through dawn-lit trees, in the crest of a Parasaurolophus calling through misty swamps. Their extinction was tragic, yes, but their existence was a miracle. The fact that we even found them at all, buried in silence, waiting to be known, is one of the great wonders of science. They didn't have to leave evidence, but they did, and maybe, most of all, they teach us about legacy. The bones in the rock are mute, but the stories we've built from them are full of life. In books, in films, in conversations between scientists. In the wide eyes of kids with toy raptors, dinosaurs continue. They shape our dreams of what once was and what could be again. They remind us that even in loss, there can be meaning. That even after death, a creature can inspire awe, love, curiosity, and respect. So what do dinosaurs still teach us? They teach us to look deeper, to think bigger, to listen longer. They teach us that the earth is older, wiser, and more resilient than we think, and that our time here is precious. They teach us that life always returns, that the silence after extinction is never the end, it's the beginning of something new. And they teach us that we are part of this same story, not separate from nature, but written into it. Living fossils ourselves, walking through a world shaped by everything that came before. The dinosaurs may be gone, but their time never truly ended, because we're still here, and we're still listening.